Okay. Well, thank you everybody for joining us today. My name is Julie. I'm the events manager at Roundabout Books. So if you've been to one of our live events in the last year or so, you've probably gotten to see me. And we're so grateful to be able to continue events via Zoom and make sure that everybody is safe and healthy while still getting to hear about these amazing books that we have in our store. So today we are going to talk with Daniel Mathews about trees in trouble. If you're unfamiliar with how Zoom works, at the end of the event, I will be unmuting people who have questions. So there's a couple different ways we can do that. If you have your camera on, you can always raise your hand and I can visually see that. Or there is a function in both the chat and just on your screen that will say raise hand, and that gives me a virtual hand, or you can type something in the group chat. If you want me to read the question, we'll do it that way. Don't forget this book is available for purchase at the bookstore. If you're not local to Bend, you can always give us a call. It's 541-306-6564. And we are recording this for YouTube. So if you know of someone who wasn't able to join us today, please refer them to the Roundabout Bookstore YouTube account or website, and we'll have that posted. So let me tell you a little bit about the book we are hearing about today. So Trees in Trouble, Wildfires, Infestations, and Climate Change by Daniel Mathews tells the urgent story of this loss accompanying burn crews and forest ecologists as they study the myriad risk factors and refine techniques for saving the important limited resources. And oops, pardon me. And as most of you know, here in Central Oregon, we were founded as basically a forestry economy with the mills, and we love our green spaces and forests, and they are in danger. So we're really excited to hear from Daniel Mathews, who is also the author of Natural History of the Pacific Northwest Mountains, Rocky Mountain Natural History, and Cascade Olympic National History. During a career of writing about the natural history of Western North America, he has backpacked far and wide, watched for fires from Desolation Peak Lookout, witnessed a 40-foot fir crash onto his family's house in a storm, and lived for years in a forest cabin without electricity, heating with firewood, and writing by kerosene lamp. He currently lives in Portland, Oregon. So thank you so much for joining us, Daniel, and I'm going to turn it over to you to talk to us about Trees in Trouble.
All right, thank you, Julie.
Oh. It
looks backwards to me. What's wrong here? Anyway, I'll share an image of that with you in a moment. This is a great opportunity. One of the opportunities I see in doing this is I can bring in some really recent information. I can also show you a lot of pictures, which I couldn't do in the book. So I'm going to basically go through the book chapter by chapter, adding a lot of pictures and telling you about what's in those chapters. I'm going to imagine that my audience is people of Central Oregon. I have no idea whether that's actually true, but it kind of honors the tradition of author appearances at bookstores and adds some local color. So that'll be my assumption. And here we go. I'm gonna start showing slides. So that's the book. I'm going to start with the first chapter is kind of an introduction to the ponderosa pine forest, the low severity fire regime, and why that is something that needs restoring and can be restored, and actually has been restored to a fair degree in a number of places in Central Oregon. This is a historical photo from 120 years ago in Eastern Oregon. It shows what forests often looked like in those days. I'm going to read a description from even 50 years before that from a couple of pioneers on the Oregon Trail, because it's such a beautiful little description and accurate. perceptive about what's going on ecologically. Our drive of the forenoon of September 8th was still among the pine openings. The atmosphere was loaded with balm, balm meaning fragrance. I can almost say I never saw anything more beautiful. The forest so different from anything I've seen before. The country all through is burnt over. So often there is not the least underbrush, but the grass grows thick and beautiful. It is now ripe and yellow, and in the spaces between the groves, which are large and many, looks like fields of grain ripened, ready for the harvest. Of course, being a pioneer intending to farm, she's thinking about harvest. And here's an image of a rather similar forest today, not in Central Oregon, right by Highway 31. I saw lots and lots of forests that look kind of like this, and that's been with the aid of some prescribed fire. You can see a tiny bit of charring at the bases of the trees. They can get a lot more scorched than that. They can be blackened 6 and 10 feet up. And because of the way the bark works, slowly over the next several years, flakes of bark will just pop off in the afternoon sun, and the tree will return to its golden bark color, except in the crevices, which will remain black. And one thing I want you to notice about this is you can easily imagine in both this picture and the last one how fires could come through at the surface layer, and they would not be, the flames would not be high enough to catch the lowest limbs on the trees. And so that's the characteristic that ponderosa pines evolved into, where they tend to foment low severity, low fires by adding all this great tinder, pine cones and pine needles to the forest floor, which are flash fuels. They easily catch on fire, but they don't raise really tall flames. And if that happens often enough, then it prevents tall brush from growing. You may notice also in the difference between this picture and the last one that it's not so much grass like pine grass in this picture. It's kind of brushy. There's a little bit of bitter brush, and that's great too. It doesn't have to be grass. Bitter brush is an excellent plant. It fixes nitrogen, and it's terrific browse for elk and deer. So when I began researching this book, one of the first things I did was I went along on a field trip in Southern Oregon on the Fremont National Forest with Jerry Franklin on the right, and his frequent collaborator and sidekick, Norm Johnson, on the left, and Jerry's dog, Strider, one of several dogs named Strider that he's owned in succession, all golden retrievers. And so he was taking a number of graduate students around to show them and to actually try out things like marking trees for a project and for thinking about how prescribed burning is going to work. And of course, the prescribed burn here would take out most of these small trees that are coming up. And that's what keeps the forest thin and keeps the big trees able to survive, as they have done for hundreds of years in the West. He also took us to this corner outside of Camp Sherman in Central Oregon, where the Forest Service kindly put on a number of demonstrations and then asked the public to vote on which kind of treatment look they liked best. In this picture, you'll see some of the trees do look like they may be charred to a greater height from a prescribed fire that's been done here. But as you see, a few years after the fire, it looks great. The next scientist I write about in chapter 1 is Hugh Safford. He's on the right in the bright blue. This is one of the biggest ponderosa pines at Emerald Point on the shore of Lake Tahoe, California. That area mostly has ponderosa pine's very close relative, Jeffrey pine, which is basically similar in most ways. It has the same fire ecology, but there at Emerald Point, it's unusual in being moist enough apparently for ponderosa pines to grow in amongst the Jeffrey pines. And They have reached a great age. As you can see, that one's probably 600 years old. Chapter 2, Inferno, is about fires, the kinds of not necessarily low severity, medium and high severity fires. And severity, by the way, is a measure of the mortality rate of the bigger trees. So a high severity tree is one that kills most or all of the big trees, as opposed to the low severity fires that ponderosa pines evolved to live with very happily. This picture was taken just about 10 days ago near the California-Nevada border at the Loyalton fire, which generated a fire tornado, a very rare but possibly increasing phenomenon, since we had another one in California just 2 years ago in the town of Redding. We'll get back to that later. I visited the site of the 2011 Las Conchas fire in New Mexico because it was one of the most severe megafires. It came in a succession of fires, which is what enabled it to consume so much of the forest that was there. I was hosted by Craig Allen, who took this picture. And that's him in this panorama that shows a sort of a wider view. And it shows that's 8 years later, not all that much had grown back on the site. And this is part of a very disturbing trend that in the middle of large high severity patches in megafires, it's very hard for forest to come back. And farther south, like in New Mexico, this probably will never come back to forest. And it was forest. You can see over at the left-hand edge, there is a tiny patch of surviving ponderosa pines. Somehow they escaped the fire, both the succession of fires that came through here, and are still green. And that's what covered this landscape before 1995. Here's a rather different look. This is just 1 year, two years after the Hanceville megafire in central British Columbia. It was only the second biggest fire in central British Columbia that summer, the terrible summer of 2017. And still at second biggest, it was still larger than any megafire in forests in the US that we have in recorded history. And a strange phenomenon happened here. Now, this was not, this did not follow another fire, so it was not able to consume the trees that it killed. And that's typical. But it did this really interesting thing, and what I interpreted, these were lodgepole pines, and as you see, they weren't very big, only about 8 inches diameter. And I think the fire was so hot that it basically steam bent these trees. It softened them so that the winds that accompanied the fire bent them over into this shape. And then when they cooled down, they retained the arced shape. As you notice on the forest floor, there's nothing. It's just mineral ash. The small plants and the mineral and the organic soil and duff were all consumed. It was very hot here. And it produced a lot of smoke, those giant fires. This is a satellite image of Oregon and Washington, southern British Columbia, from the summer of 2017. Down, let's see if I can, nope, the cursor's not working, but if you can pick out where Central Oregon would be, and in the Cascades, the biggest plume of smoke there is the Whitewater fire on the west side of Mount Jefferson. But most of the smoke that covers the upper part of the picture is drifting down from those giant fires in British Columbia. Just a couple of weeks after this, though, the fires in Central Oregon got going, and it looked more like this. The wind is blowing from the south, so Bend is getting hit really bad, as some of you may remember. And this is a map showing a sort of a composite image of about 20 years worth of fires in Central Oregon. You can see they covered a lot of the forest, but mostly at the Cascade Crest and east of the Cascade Crest. The forests on the west side of the Cascade Crest are still moist enough that they don't burn all that much, nothing in comparison. And the same is true farther north in the Cascades, where the composite image shows even a higher percentage of fire over a large area. This is the Okanagan-Wenatchee National Forests. And this is a considerably bigger area in this image. And the amount covered by fires would be even greater if it went back to 1994, when they had a really big one down where the word Chelan appears. But this is about 18 years worth of fires, including the worst year there, the worst 2 years there, which were 2015 and 2016. Moving on to chapter 3, outbreak. It's about the huge outbreaks of pine beetles that the West have seen. This is a picture taken in 2016 in the Sierra Nevada at Bass Lake, which, as you can see, is a popular recreation and vacation home lake. These are mostly sugar pines and ponderosa pines killed by different species of pine beetles, bark beetles. Also, there was a bark beetle hitting true firs, so that's some of the mortality. And then they even started hitting incense cedars, which at first had appeared to be resistant. Here's a close-up of what western pine beetle looks like. A ponderosa pine cut and the bark peeled away. A big piece of bark showing the characteristic spaghetti-like patterns that particular species of pine beetle leaves under the bark. And then it also brings a fungus with it, which helps provide food for it. It's what the larvae actually eat is primarily this fungus, and the fungus is called blue stain fungus because it stains the wood blue, as you can see. And there's the beetle itself. I wonder. It's tiny. It's about the size of a grain of rice, and it's black, and that's what the adult looks like. It's the larva, of course, that does most of the active damage, eating underneath the bark of the tree until it girdles the tree. Of course, one larva can't do that, or even the progeny of one adult cannot do that. It takes a mass attack of dozens of bark beetle adults, giving birth to hundreds of larvae to kill a tree. This is the entomologist Diana Six doing an increment borer to get a sample of the tree rings from a lodgepole pine tree. She's pulling out. In the center, you can see the pale strip about the size of a pencil is the core, the core from the tree. This is a different kind of sampling of a tree. That's a wood cookie. It's more useful if what you want to get is not just the tree rings, but the fire scars. Typically, ponderosa pines in a typical ponderosa pine forest will have 5, 10, 20, 30 scars of many fires the tree has lived through. It starts getting the kind of recording scars when it is burnt severely enough that the bark and cambium are killed on one side of the tree. And then once that's happened, each successive fire that starts to char the already charred part on that side of the tree will make a fire scar. And the long-term record looks kind of like this. Oh, sorry, we'll get to that slide later. This is the tree ring god, as Diana Six called him, Tom Swetnam, at his retirement home in Jemez Springs, New Mexico. That pile of rocks in the background or in the middle ground of the picture is actually the ruins of a Jemez Indian field house. There was a pretty large population in this area. And on his property, he has a couple of these field house ruins and also some really unusual artifacts called cupules carved into bedrock. And this is the cupules. They're a few inches in diameter, and the anthropologists don't really know how they were used. It was probably ceremonial. A larger and broader, shallower indentation called a metate is much more common, and we know what that was used for. It was used for grinding corn, because that practice, of course, continued or continues to the present day, especially in Mexico. The originator of tree ring study was Andrew Ellicott Douglas, and this is a historic photo of him in the 19-teens on top of a sequoia stump. In that day, people didn't even know how to recognize what was an old tree. They had no idea, because they didn't have increment borers. They hadn't counted enough tree rings. They didn't know how to recognize from the outside what was an old tree. So he started out by figuring the oldest trees must be the biggest trees, the giant sequoias. So he went and started cutting with, cross sections out of the center of old sequoia stumps. So here's a modern tree ring laboratory. The microscope has been replaced by computerized microscopes that bring up the image at various levels of magnification on computer screens. The one at the top is a really close-up of the tree rings, and it can very instantly measure the pattern of wider and closer tree rings to instantly recognize what year this probably was, based on the pattern of larger and then smaller, which all reflect climate. Then the image at the bottom shows a fire scar cross-section with multiple fire scars. Here they've been marked by year, the year 1751, the year 1729, and 1710, and so on, going back to 1618. A fire in 1618 is recorded in this sample. And this is in the lab of Tom Merschel Andrew Merschel in Corvallis at OSU. Here we move on to chapter 5, which is about the southern fringe of conifer pine growth in the US, the pinon pine zone. This, of course, is at Mesa Verde and shows a pinon pine forest impacted by the fire of 2008 in Mesa Verde National Park, and that's one of the famous cliff houses below it. Mesa Verde National Park, not that long ago, 25 years ago, was completely covered with pinon pine forest, and then it was hit with a succession of fires that almost took out the entire mesa. This is a map showing the succession of fires, and the pink outline is the outline of the national park. And as you can see, most of what's within that park has been burnt since 1996. Pinon pines have also been hit hard by their own kind of pine beetle, especially starting in 2002. But this is a more recent beetle attack at Walker Pass in California, the lowest, the southernmost pass in the Sierra Nevada, or the northernmost, I should say. It's at the southern end of the range, but it's the northernmost for quite a ways that is crossed by a highway. Chapter 6 is about thinning and burning, especially prescribed fire. This is a very modern prescribed fire. It's being ignited by a helitorch strung below a helicopter. You can see both the chopper and the torch there. And this is modern science studying prescribed fire. I went and visited a fire that was done partially or largely for the benefit of scientists who were looking at it really closely in many ways. There were a couple of different outfits using drones to watch this prescribed fire once it got going. This drone was going to capture air directly over the fire and measure the contents of the all the smoke in the fire. And they have been finding that prescribed fire smoke is nowhere near as toxic as wildfire smoke. And that's one of the reasons why we would benefit greatly if a lot of the wildfire today could get replaced with prescribed fire. This group was from the Desert Research Institute in Nevada. Another team was looking at the prescribed fire with cameras that register infrared as well as visual light. And they're coming up with imagery like this, which I think is really cool. You can see the infrared heat of the fire rising in a plume, the fire in the center, and all those green trees picked out in the imagery below it. This group is from the University of Montana. And this is a picture showing the changes that have happened to forests over much of the West. Pictures taken in 1934 and 2010, aerial photos, and they show how much the forest has increased in density. This is in the eastern Cascades of Washington, near between Chelan and Wenatchee at Mission Ridge. Because we've been putting out fires, the trees have grown back and greatly increased the density and the proneness to high severity fires of this type of forest. This picture was taken this year. I forget the name of the fire. It was a really small fire east of La Pine, and it shows the benefits of thinning and burning. Left of the road, the forest was really dense and nearly all the trees were killed. I suspect the reason the trees next to the road were stayed green is maybe they were hit with some water by the firefighters as the fire approached. But as you see from the blackened trunks on the right side of the road, the fire did cross the road. It did blacken all those trunks, and yet it did not kill the trees. They had no underbrush to speak of, so the fire was low there and did not kill the trees. So that's what we're trying to get back to. In the southeastern US, they have maintained their tradition of prescribed fire every few years in a lot of forests. It just was handed down from parents to children and managing forests all along, and it's completely accepted there by the populace. And this is a wet longleaf pine savanna, which is maintained with fires every 3 or 4 years in North Carolina. Chapter 7, I don't have too many pictures, but this is a redwood tree planted how long ago? Probably 40 years ago on San Juan Island in Puget Sound. So, or I should say the Salish Sea. So it's hundreds of miles north of the normal range of redwoods, and yet it's doing just great. I visited with a guy who's running a program, mostly in British Columbia, but also in several states, of trials of trees from various parts of the West. Most of them planted north of their historic range to see how well they do. And he told me about many sequoias planted even in central British Columbia, giant sequoias, and they're doing just fine so far. So, the trees are going to migrate due to climate change. They're going to move north and uphill. And but they're not going to be able to move fast enough to keep up with climate change. So some foresters, not all of them, but some foresters believe that we would really benefit from planting trees northward, tree species, and especially just more southerly provenances even of the same species north of where the parent tree grew, because that way we'll get trees better adapted to future climate. Now, when I say that sequoias and redwoods are doing great way north of their historic range, they're growing, they're not necessarily reproducing there, but those particular trees are, they tend only to reproduce following a fire. So that may be what's needed to get natural reproduction once we have full grown trees farther north. Chapters 8, 9, and 10 are all about the especially bad threats to whitebark pines and other white pines. If you've hiked in the Central Cascades, you've probably seen plenty of these white ghost trees. After whitebark pines die, they remain on the landscape. They turn white and just remain standing for decades. Look like this. This, of course, is taken on the side of North Sister, looking north at Mount Washington, Three Finger Jack, and Mount Jefferson. And when I hiked in that area along the west side of Three Sisters just last year, I did not see any good-sized whitebark pines, except dead ones. They're attacked both by mountain pine beetle and by an exotic disease called white pine blister rust, which arrived on these shores in 1911 and proceeded to pretty much wipe out western white pines. Well, that's an exaggeration. There's still a lot of western white pines are still extensive. I see them from time to time. I see them reproducing, producing cones, but the population level is a tiny fraction of what it once was. And in fact, up until the 1930s, it was the top timber species in Idaho, and a fairly important timber species in eastern Washington, but not anymore. There aren't enough of them. One of the leading researchers on white pines, who did a great deal to show this amazing and fascinating symbiosis between whitebark pines and Clark's nutcrackers, a bird which is almost entirely responsible for planting all the whitebark pines that we see growing today. In caches that it plants for its own food source, but then it plants more than it needs, more than it can eat, and the ones that it doesn't come back and eat can grow into trees. And thus whitebark pine is able to spread, especially into burns, miles and miles, because Clark's nutcrackers carry the seeds miles before caching them. And so it gives it a big leg up in reforesting burns. However, today it's so threatened by white pine blister rust that we're not sure it's going to be able to keep doing that. So this is Diana Tombach's current research site just outside Yellowstone National Park. Those are the peaks index and pilot that look down on the research site. And this picture is what the cankers of white pine blister rust look like. And this is how you see that it's going on, and it's in the process of killing this little tree. Now, there are really interesting and great efforts underway to protect white pines from white pine blister rust by going through forests that have been attacked and finding the mature trees that survived, possibly for random reasons, but also possibly because they happen to have some genes that resist white pine blister rust. So we collect the cones and seeds from those trees that may be resistant. They call them plus trees, and they plant the seeds in these trials in several locations. The one I visited is in Dorena, Oregon, outside Cottage Grove. And then they wait, and then they intentionally infect them with spores of white pine blister rust and wait to see which ones don't die. And then when those grow enough to produce seeds, then the seeds will be able to be planted, and with fairly high confidence that at least for some decades, they'll be able to survive attacks by white pine blister rust. They may not resist it entirely. They may not, they may lose some branches, but hopefully they'll survive and grow and reproduce more resistant trees to have future populations of these trees. And when I say white pines, I'm saying all the pines that have needles in clusters of 5. So that includes sugar pines in California, and more than 10 species of pines in the West. This picture I took just because it was kind of funny to see after some of the resistant pines succeeded in growing in their little boxes, you get these ridiculous size and number of trees densely planted in a small box. I don't know how they survive with such a limited rooting area. I end the book, or almost end it, with a hopeful chapter, The Enduring, about bristlecone pines, because these are the trees that, even though they are white pines, are survivors. They're the oldest trees in the world. Some of them are more than 5,000 years. We don't even know, maybe some of them are more than 6,000 or 7,000 years old. The oldest one is over 5,000, and no one today knows which one it is. We have the cores from it, but the guy who recorded where the cores were taken destroyed the record of where that was, and then he passed away because he didn't want people going and taking souvenirs and possibly threatening this oldest tree. When I walked amongst the groves of bristlecone pines, I thought they were the most beautiful groves I've ever walked in. Now, bristlecone pines usually look dead because they've lost their bark on, the really old ones have lost the bark on most sides of the tree. It's called the strip bark growth form. They survive with just a strip of bark running up one side of the tree that is surviving and growing and keeping some of the branches supplied so they can have green leaves. And you might think this is, it looks like they're going to die soon, but it doesn't mean that at all. They're the greatest survivors in the world. And here I'm just going to show you some more beautiful pictures of bristlecone pines. This one shows how it does have a green side, even though it has a lot of dead sides. It shows how contorted they can get. I can't even explain why the bark sometimes creates patterns like this. Then after that chapter, I have a chapter called The Afterword, because while the book was slowly going through production, I got to revisit some sites in California, which I thought were worth revisiting. This one, I realized it's on a hike from Tioga Pass in Yosemite National Park, and it's the healthiest big stand of white bark pines I've ever seen. It has very few ghost trees and no trees that have red tops because they're in the process of dying from white pine blister rust. It happens to be where, or very close to where Diana Tombach did her dissertation research 40 years ago. And it made me really happy to see that there are still some healthy stands of white bark pine. Much of what I went to revisit in the afterward trip was not so happy. This is the scene of the car fire in Redding, California, which was very severely burnt, and thousands of houses were destroyed. And they're already rebuilding pretty fast, and some of the people have put out memorials, including this one. This was the site of the other big fire tornado. This is in Paradise, California, which I'm sure you know about, the town that was completely wiped out by the Camp Fire a couple months after the car fire. But there was an interesting thing I saw in Paradise, which was that there are a lot of green trees in the town, which means the rate of survival of the canopy of the overstory trees was high enough this would not be classed as a high severity fire at the location of Paradise itself. It was high severity on its way to Paradise. But once it got there, it kind of dropped down, and it was the houses that carried the fire. And that's a really strong lesson of why towns might not be hit so badly by fires if enough of the houses were seriously fireproof. And it is possible to do that. Interestingly, this particular tree was a coast redwood, which had to have been planted probably just 30, 40 years ago. It wasn't real big. So it was outside of outside the historic range of redwoods. And its needles were completely consumed by the fire, but it did not die. And the very next year, this was taken just a year after, 11 months after the fire. 11 months after the fire, it had done all this resprouting, heavy resprouting from the base, from the roots, and also resprouting all over these limbs. So this tree is probably going to look pretty good in another 20 years. And I find that especially hopeful when I think about the fire going on today in Santa Cruz and San Mateo counties, California. On Twitter, you can read a lot of people really freaking out about how Big Basin Redwoods State Park was destroyed. But when you read closer in those accounts they're linking to, it says the buildings were destroyed. And that's something to be upset about, because they were really adorable historic buildings and informational displays, and they all burnt down. But I'll bet that most of those redwoods are going to survive. A lot of them will survive with their canopies intact, even with some charring at the base. And others will survive like this tree did by they may lose their needles and all their green needles, but they may resprout all over the tree. And others will resprout just at the base after basically the tree dies, the above ground tree. They'll resprout at the base and create new redwoods. But my guess is that the great majority of the big old trees will survive that fire. So I'll keep my fingers crossed. I can't promise. So with that somewhat hopeful note, I'll turn this back over to Julie and questions.
Well, that was great. Thank you. It's interesting. One of our booksellers, Dylan, who was working with us earlier this year and last year, his parents lost their house in the Paradise Fire, but they're okay and they're rebuilding. So would you say that prescribed burns are something we should be doing? I know we do it a lot here in Central Oregon, but I know a lot of people are, maybe against it, or there's a lot of replanting. Is it possible we're overplanting?
Well, that's a couple of really different questions. There is a risk of overplanting in the sense of forest getting too dense, because as I explain at a lot of length in the book, denser forests do tend to be more prone to high severity fire and more prone to beetle attack and more prone to just direct drought mortality. So we would like at least, you know, there are also forests in the West, like spruce fir forests at high elevation and like lodgepole pine forests that are just naturally dense. They're always going to be dense. So when I talk about needing the forest to be less dense, I'm just talking about the types of forests that are adapted to low severity fire. But those should be less dense, so we don't want to replant them too densely. And part of how we can get them back to being less dense is prescribed fire. So yes, absolutely, I think we should be doing more prescribed fire. And, you know, people are coming around to seeing that. Opinion surveys find a lot of support for prescribed fire. And it varies a lot from location to location. Towns like Flagstaff, Arizona, Santa Fe, New Mexico, and Camp Sherman, Oregon, seem to be totally on board with prescribed fire right around their towns.
Yeah. Yeah, and we do have a fire in Camp Sherman right now. So
yeah,
it's definitely an area. We went camping there a couple of weeks ago and it's beautiful. We have a question in the chat. So Kathleen is wondering about the wildfire smoke versus prescribed smoke details. So why is the wildfire smoke more dangerous?
You know, I don't have that answer at the tip of my tongue. Okay. Part of it is undoubtedly, you know, the two big factors. One is burning at higher severity. Different volatiles get released, and a lot more of them. And the other is burning development, habitations and structures, and you know, the smoke from structures is terribly toxic because there's so much plastic and petrochemical products in modern structures. So prescribed fire is done carefully enough 99% of the time that it doesn't burn structures. And I have to admit there is that 1% of the time when things are going to go wrong and it may burn some structures. And there are some sad examples of that, of course. The Cerro Grande fire is the worst so far in the US, and that was how many, 20, I think more than 20 years ago. But they're getting better
let's see
at avoiding that.
We have another question. So it says, in Australia, the Aborigines traditionally burned patches to enhance food-giving resources, a practice over tens of thousands of years. Did Native Americans also practice burning?
Absolutely. Yeah, good point. And sorry I didn't mention that. Yeah, and when settlers first arrived, especially in California, they a lot of the earliest settlers adopted some of those practices and learned them from the Indians. And then there was this huge change of opinion. Mainly, you know, there were fiery debates going on for a while over whether that was good or bad. And in 1910, the terrible fires of northern Idaho and Montana, it was the worst fire year ever in the US. And it kind of won the argument, sadly, for the people who were against fire, and the Forest Service started trying to put fires out as much as they could. And they didn't actually even get good at it really until the 1940s, when there was a lot of surplus aircraft left over from the World War, and they were able to put those to use fighting fires, and they got a lot more mechanized, and they got very good at fighting fires. But also the trend toward preventing fires, it actually got started in the ponderosa pine forests of the West with sheep grazing in around 1870. Because the sheep would graze the grass so heavily that you no longer had enough grass to carry the fire from one tree to the next. So the drop off in the amount of fire in these forests started in around 1870. And it got somewhat worse in 1910, 1915, and then a lot worse in 1950.
Yeah, interesting.
Did I cover all the question? I forget. Native American practices, yeah, and they're leaders in some of the tribes are leaders in bringing back prescribed fire, and they're doing it on their own way on some of their reservations.
Yeah, That's interesting. And I know around this area we get really nervous because we see the smoke. And I have a friend whose partner actually is a lead plane pilot for the Forest Service. So he flies and maps the fires, and then they dump the water. But every time I see smoke, I text her first and I say, is this a fire or a prescribed fire? Because, you know, in this area, we're pretty prone to wildfires, just everything that's around us. So I
Yeah.
think it makes people nervous, and we don't quite understand that the prescribed fires are going to help not have so many uncontrolled wildfires. Let's see here. So we do
Yes,
have one. Go ahead.
there's some great web resources for answering that question if you want in the future.
Okay.
Maybe you prefer to call your friend, but
Yeah.
one of the websites is INCIWeb, INCIWEB, and then there's one local to Central Oregon that I can't tell you off the top of my head, but if you Google Central Oregon Fire, I think you'll come up with the Central Oregon Fire something website, which would keep you up to date on where the prescribed fires are.
Yeah. Yeah, because it's like I said, we see it a lot, and it feels like it might be later this year because it is, you know, already the third week of August. But
Right.
that's
Generally, right now, you're going to see wildfires, and the prescribed fires are going to be in spring and fall.
yeah. So we have one more question. It says, is there collaboration with another area in the world similar to Central Oregon about forestry and fire? Kathleen, I'm a little confused by the question. So I guess maybe, are we doing a good job in this area of kind of like with our prescribed burns?
You could do even more, but you're doing a relatively good job. Yeah.
And we have one more. Let's see here. Is there a role for prescribed logging, or is it not as effective as prescribed burns?
For some things, it's more effective. For some things, the burning is more effective. There's a role for both, in my view. I know there are people who won't like hearing me say that and will disagree. But yeah, I mean, Jerry Franklin was a great hero to all forest activists in the 1980s and 90s, and now a number of them are pretty mad at him because he always kind of believed that he wanted to find a way to continue some level of logging in the Northwest, and especially when he moved to looking more at ponderosa pine forests rather than the west side forests, he decided that a lot of them really need some logging because they're already too dense, and and that makes the prescribed fire too risky,
Right.
too risky that you're going to lose the big old ponderosa pines that you're trying to save.
Yeah.
And in particular, there's an issue right now about getting rid of the so-called 21-inch rule, which says that when they do thin, they can't cut down any trees bigger than 21 inches. But when I was with him, he was pointing to some grand firs, which were bigger than 21 inches, but he said they're not really old, and they're not and they're not really what would be ideal here. Just they're not as resistant to fire and beetles as ponderosa pines, and it would help this forest to cut some of the grand firs that are less than 150 years old, but bigger than 21 inches. So that's pretty controversial
Yeah.
with the environmentalists who don't want to let go of that protective rule.
Yeah. Let's do one more question. It says, is there any hope for reducing insect infestation in our forests?
For using them?
No, for reducing insect infestation.
Not really a great hope. They really don't have really great tools for reducing them. As I've been saying, if you thin some of the ponderosa pine and true fir forests and Douglas fir forests, that will help a little bit. But the worst attacks of mountain pine beetle are in lodgepole pine forests, and there are no studies, really no tests, which have shown that you can do much about them, about the pine beetles in lodgepole pine. There aren't good results from thinning. There's no point in really thinning.
Yeah. Okay. Well, actually, we do have one more. I know I said that was the last, but this is a great question for our region and our listeners. What tree do you recommend we plant on our property in Bend, Oregon?
You know, I'm not really an expert, but off the top of my head, if it were me, I would look at incense cedar, which is actually just within, yeah, it's within its historic range, but it's toward the north end of its historic range. Let's see. Ponderosa pines, especially if you can get seeds from farther south.
Okay.
And you could try a giant sequoia. I'm not sure how they would do.
Yeah. Interesting. That's
they might need some watering.
Yeah. That's good to think about.
Well, but insect cedars are more resistant to insect attack.
Okay. That's good to know. Well, I want to thank everyone for joining us. Daniel, I want to thank you so much for taking the time out on a Saturday afternoon. And from the background, it looks like it's glorious weather where you are right now. So again, thank you so much. If anyone is interested in this book, please give us a call at the store. And if you have more questions for Daniel, I think you're on some social media. Yes, you're on Twitter?
Yes.
Okay, what's your Twitter handle?
Mathews, PNW.
Okay, excellent.
Well,
yeah, this is a really good topic to be learning about for everything that's going on in our world right now. So again, thank you so much for being here. And yeah, for anyone who wasn't able to join us, you had friends that might be interested. Now that you've heard about it, please direct them to our YouTube channel. So I think we'll go ahead and wrap it up. And everyone in the chat is saying thank you. We learned a lot. Let's see here. Very good information, informative book. So yeah, thanks again.
All right. Thank you. I was glad to have the opportunity.
Excellent.
Thanks for listening.
All right.